Hello everyone, and thank you for joining us online. First of all, let me welcome you to E2S Thermal Energy Storage Technology presentation. My name is Miloš Maksimović, and I will be your host, and I will guide you through this event. The energy transition to carbon neutrality is one of the most important topics today. Major companies, governments, investors, and entrepreneurs are all working on new initiatives and solutions. Huge progress has been made in the transition to renewables. Since the sun does not always shine and the wind does not always blow, all agree that energy storage will need to be part of the solution. Today, Saša Savić and Fabrizio De Candia will offer insight into thermal energy storage integrated into existing power plants, a solution that is innovative yet simple. We will start with a short video on E2S Power and their proposed solution.
As we strive for a carbon-free world, the share of global power generation from intermittent renewable sources is increasing rapidly. The challenge in the coming years will be how to keep the lights on. How are we going to address the need for dependable power generating capacity and grid stability? How do we best use the valuable existing infrastructure in the power plants being decommissioned, preserving jobs and transitioning local economies to clean power? E2S Power has developed thermal energy storage technology designed to be integrated with existing power plants, replacing the boiler with a thermal storage unit, which stores power from renewable sources in the form of heat. The existing steam turbines can then be used to convert heat back into power.
Our solution combines heaters, storage, and steam production in one compact unit. Electricity is converted to heat and back to electricity without using air or other media. The energy can then be stored for several days and released when required.
Our energy storage solution is based on the traveling wave principle, utilizing two sets of storage blocks. The system is self-regulating and doesn't need any additional control equipment. During the charging process, the first set of storage blocks is heated to very high temperatures of about 700 degrees, whereas the second set is heated to temperature required by the steam turbine. In the discharging process, steam is initially generated in the first set of blocks at the temperature close to 700 degrees, and then it's cooled down by the second set of blocks to the turbine inlet temperature. During the process, the heat is moved in the form of traveling wave from the hot to the moderate thermal storage blocks. Energy storage materials are based on Miscibility Gap Alloys, which are developed by our Australian partners MGA Thermal. These blocks consist of graphite and aluminium. The aluminium, during the charging process, is heated to 660 degrees when it melts, absorbing a lot of latent heat. The graphite acts as a matrix, keeping the block solid and embedding the melted particles.
The materials used have a long life, are abundant, safe, and recyclable. Our technology has been validated in our demonstration facility in Belgrade. This has provided valuable data on the storage properties, material selections, and steam generating capabilities.
E2S Power is working with major power utilities in Europe on a 50 megawatt-hour pilot that will be integrated with an operating plant next year, an application in existing coal plants scheduled to be phased out. This is paving the way to commercial scale expansion in the next 2 years to meet the huge global need for storage utilizing potentially stranded assets. We have seen recently volatility in electricity prices and blackouts related to weather events. These are early indicators of the importance of security of supply as we transition to renewable energy and phase out fossil fuel power plants. As part of the solution in years to come, our thermal energy storage system integrated with existing power infrastructure can play a critical role.
Government of Montenegro, together with our national energy company EPCG, trying and looking to develop different kind of projects to help us to develop our national energy strategy, going to green energy and going to zero carbon emission. We're looking to find our external partners to develop these projects, and one of them is E2S. We're developing different kind of projects with them, with the renewables, with the solar and wind, and especially with energy storage, what we're going to try to implement very shortly in a coal plant in Pljevlja.
After this interesting introduction, I'm sure that video sparked your interest and you have quite a few questions. All of your questions can be submitted in our chat underneath your streaming window. So feel free to submit your questions at any time during our session. We will read your questions, but not the name of the person who submitted it, and we will try to answer all of them during our Q&A session. Also, this whole presentation will be available on E2S Power YouTube channel immediately after this event. Now I would like to introduce you to our speakers, Fabrizio De Candia and Sasha Savic. Mr. De Candia has over 30 years of experience in the energy industry, including development, investment, operations, and engineering and construction in Europe, North America, and India. In addition to his role at E2S Power, he currently serves on the Investment Advisory Committee for NTR, a leading renewable energy company. Dr. Savic has professional experience in the power industry spanning 30 years, primarily in thermal power plants and energy storage. He is an author of more than 15 patents in the field, with the most recent ones on thermal energy storage solutions. After 15 years working at Alstom, Sasha founded Ssna Power Group and most recently the E2S Power Company with a focus on energy storage. Fabrizio and Sasha will provide insight into the market drivers for thermal energy storage and how E2S Power's technology works. So gentlemen, please, the floor is yours.
Thank you, Milos, for this introduction. Thank you all for joining us on this online event. Let me use this opportunity to give you some insights into where do we come from, what are the companies that are behind this project and this initiative, before we actually dive into a nitty-gritty of the technology. So the West energy storage technology will be the topic of today's discussion, but before that, I would like to introduce you to our Ssna Power Group, which is, let's say, behind all these activities. The Ssna Power Group was formed some 8 years ago with the intention and vision to develop solutions and designs and engineering to support the transition to a carbon-free future. The Ssna Power Development is the developing arm of the company, which is headquartered in Switzerland, and it holds controlling packages of 3 companies. One is the G2P Adriatic, which is focused on building a first hydrogen-based gas turbine power plant. The other one is S2P Electric, which is mainly focusing on developing solar projects, especially in Southeast Europe, where there is a lot of sun and the market situation is quite relevant. And of course, the E2S Power, which is focused on developing the energy storage solution, and we'll talk about that in a minute. In addition to this development arm of the group, we also have Ssna Power Consultancy, which is a global leader in gas turbines maintenance consulting, and it's also focusing on transitioning these gas turbines to function in the hydrogen-based economy in the future. And we also have our engineering group, Ssna Power Engineering, which offers a wide range of engineering services like mechanical, electrical, I&C, so controls, instrumentation, design, both internally within the group as well as to the third parties, to the external companies. The Ssna Power Group is, within these 8 years, has managed to operate on all the continents, and we are operating in more than 30 countries around the globe, with offices. The headquarters is, of course, in Switzerland, in Wettingen, nearby Zurich, but we also have offices all the way from Japan through Indonesia, Malaysia, throughout Europe, and then in North America as well. So what is probably the most interesting for all of you today is the E2S. E2S is a joint venture between Ssna and Vika. Vika is our major partner and investor, and they are actually market leader in measurement technologies, in manometers and thermocouples. And I would like to use this opportunity also to hear a few words from the CEO and one of the owners of the Vika Group from Germany, Mr. Alexander Wiegand.
Hello, everybody. As a global market leader in the field of measurement technology, Vika is also putting tremendous efforts to support solutions leading to a sustainable and CO2-free future. Thermal storage is one of the key elements enabling this transition, and together with Ssna, we created the E2S joint venture. We strongly believe that this innovative technology has the potential to be the market leader in energy storage while reusing existing infrastructure and employees from the old coal-fired plants. Thank you very much.
Thank you, Alexander. And now, Mr. Fabrizio De Candia.
Thank you, Milos. At E2S Power, we saw an opportunity to address two key trends that we saw in the energy markets. One is the ever-increasing share of renewable energy as far as the power generation globally. And two is the phase-out of major fossil fuel power stations, in particularly coal. This particular chart shows a typical daily scenario for Germany. It is for Germany, but it's very representative what we're seeing in the market and what we're going to see more in the market. Germany is one of those markets where renewable energy share is about 40% or more during the year. And what this chart shows very well is the bottom part where you have the traditional fossil fuel power station, what we call dependable baseload capacity, and some of the fossil fuel power plants that are used for following loads. So this includes coal, this includes nuclear, and some of the coal is traditional hard coal versus lignite, for example. On the gray part at the top is the intermittent renewable energy. And in the future, in the coming years, in particular in Germany, but this is true in many other countries, the coal plants and a lot of the older plants will be phased out. So we'll be without that bottom line baseload capacity. This is going to result in an ever-increasing intermittent load and more of a challenge to follow and to match that demand and supply curve. And this is what we're trying to address with energy storage. Another key example is California. Now, in California, on the other hand, we're seeing renewable energy, which is prevalently solar energy. So, and the problem, of course, is that in many hours during the day, the sun is not shining. And that particular load has to be met with gas-fired projects. There is no coal in California, but what's happening is a lot of the older legacy gas-fired power projects are having to operate and kept online to meet that load in those hours of the day to keep the lights on. So that is another huge need that, of course, California recognizes in terms of energy storage and in particular long-duration storage. The other important effect that we're seeing more and more in these markets is the volatility of electricity prices. What we're seeing increasingly is negative prices, particularly during periods where you have a lot of wind or sun, so a lot of renewable energy available, but demand is low. So this is resulting in very low prices or negative prices. A lot of times what happens in the space of 24, 48 hours, the situation reverses itself where you have much higher loads, but not as much wind available, for example, or sun. So in a space of 48 hours, we're seeing huge swings in in power. And we have seen a few episodes, particularly when we have weather episodes, sudden cold weather, as we've seen, for example, in the UK, Germany, and of course, we have a recent episode in Texas. This is an example of this is what's shown in this picture, which is what happened late last year in the UK. So we had a period where we had a lot of wind, but low demand, and all of a sudden we had a cold snap. Well, unfortunately, during that cold snap, there wasn't a lot of wind available, so prices skyrocketed. And we had a couple of events during the winter where we had prices going up to sometimes 1,000 pounds per megawatt hour. So this is where we see definitely an opportunity for storage to bridge that gap. Another interesting chart is this one, provided by a consultant. And this is what we're seeing here is the opposite ends of the spectrum. So we're seeing on the one hand is the events, the number of times that the prices are negative, which is in the blue, and the number of events where prices are above 120 pounds per megawatt hour. As we see, the trend is ever increasing, where we might see these swings on one end or the other over 10-15% of the year. So this represents a huge opportunity for storage. The other, as I said earlier, the other important trends that we're seeing is the phase out of fossil fuel power station, particularly coal. As most of you know, most of the coal will be shut down in Germany in the coming years. And a lot of the coal capacity will also be shut down in important markets like North America. This is going to result in hundreds of gigawatts of capacity being phased out. So this presents opportunity and challenge at the same time. The challenge, of course, is what are you going to do to meet that capacity that first was met by the coal. And secondly, what can you do about these stranded assets? You have valuable assets such as steam turbine, electrical interconnection equipment, cooling equipment, as well as important power plant jobs. So this is where we see the opportunity to utilize that infrastructure by integrating thermal energy storage into these facilities. Ssna now will explain how our technology addresses this and how we plan to meet this need in terms of integration with existing fossil fuel power plants.
Thank you, Fabrizio, for this good introduction from the market side. I would like to stress again that, as Fabrizio mentioned, our solution is actually targeting the existing thermal power plants. So we are not in the business of building greenfield new storage plants. We really want to utilize as much as possible the existing infrastructure, which in our opinion and in the experience is quite valuable, and it's also still good to be used for the next 20 to 30 years. So let me get you into the twist, the traveling wave energy storage technology. So I'm going to open the casing and you can see a little bit what is inside. First, you can see that we have basically, it's a relatively simple design, and it consists of three main components. The first one is the electric radiating heaters, marked here as one. They're basically taking the electricity from the grid when you have a surplus of energy in the system, when you have a lot of solar or wind and the prices are low, as Fabrizio has shown in the previous chart. And then these radiating heaters are actually transferring this energy to the storage blocks. So number two is the MGA storage blocks, which are actually storing this energy for a number of hours that you require. And a third element is the steam generator, which is basically designed serpentine, where you later on in the discharge process generate steam at the right pressure and temperature and deliver this steam to the steam turbine. Design is very compact, exactly for the reason that we are using, for example, radiative heaters, which operate at very high temperatures, something around 1000 degrees, to increase the radiation. So you don't need too much, let's say, space in between the elements. There's very little gap between these components inside of the storage system. We don't use any fluid to transfer the heat. Basically, what we are doing is from radiation to conduction. There is a conduction from the storage block number 2 to the system number 3. In this way, we don't need any additional auxiliary equipment like blowers at high temperature, air blowers, etc. We can achieve a maximal efficiency of conversion of electric energy into the thermal energy. So now let's have a look at the E2S system, the traveling wave energy storage technology. This system is our design is innovative and unique. And basically, what we are doing when we use 2 blocks of thermal storage elements, two separate blocks. First block is heated during the charging process to the temperatures close to 700 degrees. And the second block is heated to the temperature required by the turbine. So when we discharge the system, what we do, we deliver the water to the first block with the feed water pump at exactly right pressure and mass flow that is needed by the turbine. And then steam is generated in the first block to the temperature close to 700 degrees. So this is very high temperature, higher than what the turbine normally needs. Then this steam is delivered to the second block, which is at the right temperature. This second block is then cooling the steam to the turbine inlet temperature, let's say from 700 degrees to 540, for example, somewhere around that area. And this steam goes into the steam turbine. So by having these 2 blocks, what happens is that the heat is during the discharging process is moving from left to right. So if you look at the chart at the bottom, we have points in time T1, T2, and T3, and you can see the heat wave, how is it moving from the left to the right. So the heat is actually transitioning from left to the right, from the first block to the second block. So in this way, we have self-regulating system. Basically, we don't need any valves to control the steam temperature. We don't need a temperature at all. We basically have direct and self-regulating system for providing the steam for as long as it is needed. Typically, we design for 4 hours. So these T1, T2, T3 would be, let's say, first hour, second hour, and the T3 will be the last hour when we deliver still the steam at the right temperature. So that's why we call this system traveling wave energy storage. Another innovative thing that we are using in our design is the storage material, which is based on the new class of materials called Miscibility Gap Alloys. The Miscibility Gap Alloys, or MGA, are typically made of 2 components which don't mix on the molecular level. So you have, for example, in our case, we have graphite and aluminum. Aluminum melts at about 660 degrees C. So that's why, if you remember in the previous slide, we went up to 700 degrees to heat the first block. By doing that, you will melt the aluminum and you will store a large amount of latent heat in these aluminum particles, which are embedded in the graphite matrix. The graphite, on the other hand, does not melt and remains solid throughout all the process. This is what you want for ease of operation. And in this way, if you see the chart to the right, we can actually store much more energy because of the phase change than, let's say, if we wouldn't do the phase change of the aluminum. This system has been developed by our partners, MGA Thermal, with whom we have a 2-way exclusivity agreement, and we work together on delivering this system to the market. So in the last few months, we managed, despite the corona situation and all the limitations that we had, to actually build a test center and build a demonstrator unit here in Belgrade in our test center facility. This demonstrator is basically identical to the real case storage elements. It's just in a smaller scale, so it's about 0.1 megawatt hours. And we used it to validate our models and our calculation tools. And as you can see here on the chart to the right, we have quite a good matching with what we predicted and what happened in reality, which of course gives us a huge confidence that this system can be implemented as a pilot on a power plant and that will perform as predicted. We are currently actually working with a number of utilities globally to implement the first pilots, which will be probably around 50 megawatt hours very shortly. So to summarize our E2S energy storage solution, I would like to first say that it is really very cost effective. It is compact, thanks to all these features that we mentioned before, environmental friendly, and we have very high efficiency due to radiative heaters and no convection in the system. With this system, we believe that we can eliminate more than 1 billion tons of CO2 per annum. The system itself is self-regulated, is robust, is very flexible to be used. Materials that we use are safe, abundant. We can recycle them, so there is no negative environmental impact from our system. And very important to mention is that when it comes to batteries and hydrogen and other, let's say, thermal storage systems like cryogenic, we don't see them as a competition to our system. They're actually complementary for the main reason that we are really focusing on converting thermal power plants into energy storage systems rather than building something which is a greenfield, like what is the focus for batteries or hydrogen. So we also believe that our system, not only that it saves valuable existing infrastructure, has a huge potential to save jobs in those coal-dominated regions and actually create some new jobs. So our system is really designed for converting thermal power plants into, hopefully, in the future, carbon-free storage power plants. Thank you.
Thank you very much, gentlemen. This was quite an interesting and an innovative session, and there are a lot of questions coming up your way, so I suggest we open a Q&A session. So let's start. Sasha, I believe this one is for you. What is the lifetime of the system, and how many hours can you operate per year?
All right. So the lifetime of the system, we have designed the system so that all major components can meet 25 years of lifetime. So we don't foresee any replacement of the storage blocks, which are actually the biggest part of the system, or the steam generators. They should last for about 25 years. When it comes to number of operating hours or starts and stop cycles in the year, we have done some, obviously, market investigation, and we realized that the best way, or let's say the most probable operating regime, would be about daily stop and start, which means about 300 cycles a year. And if you multiply that with 4 hours discharge, it's about 1,200 operating hours per year. But the system is flexible, and we can operate more or less. There is no limitation from that perspective.
Okay, the next question is kind of connected to the first one and the operating hours. What is the maintenance schedule for E2S?
Right. The maintenance schedule for E2S, we have designed a system that we operate without any major outage for at least 2,000 cycles. So if you look at it, if you operate like 300 cycles a year, that's almost 6 years before you do a major overhaul where you open the system, etc. However, as with any equipment on the power plant, we strongly recommend annual visual inspection, maybe using boroscopes, which is typically a standard at any power plant.
Okay, let's move on to the next question. What is the charging and discharging time, and for how long can you store the energy? Fabrizio, would you like to take this one?
Sure, I'd be happy to address that one. So in terms of charging time and discharging time, the system, as Sasha mentioned, is very flexible. The system can be charged in as little as 1 hour if required. Typically, we see anywhere from 1 hour to 4 hour charging time. As far as discharge, again, can be flexible depending on the requirement. Typically, we see discharge time in the range of 4 hours, but we can also do shorter discharge time if required.
Okay. When you store the energy, how much is the daily energy loss? I believe, Fabrizio, this one is also for you.
Sure. So the system actually has very little loss in terms of thermal energy and can be used to store energy for several days, hours, or several days, depending on the amount of insulation. We typically see a temperature loss of less than 1% per day. So that makes it ideal also for longer type storage as well.
It seems very efficient. So the next question is kind of connected. What is the round trip efficiency of your system?
Right. So yeah, we get asked that question quite a bit. So in terms of the efficiency of the electric energy to thermal energy, that conversion is very efficient. So that is about in the range of 99%. The overall efficiency, of course, is largely dependent on the efficiency of the existing plant, of the legacy equipment. Typically, the plants that we look at the efficiency of the steam cycle is in the range of 40%. So that, at the end, will be the overall efficiency of our storage system.
Thank you. What is the long-term performance degradation of the system? Sasha, maybe you would like to take this one.
So the question is, what is the long-term performance degradation of the system? Right. So this is interesting. This is an interesting question because we are aware that, for example, batteries have relatively significant degradation throughout their operating life. We all know that from our mobile phones or those who have electric cars, that the batteries are strongly degrading with the cycles. In our case, this is not the case. We have actually designed the system. These MGA blocks, for example, they can cycle for many, many cycles without any degradation of performance. So we are currently testing that. Also, we are doing long cycle testing in Australia, and we have seen already after 3,000 cycles, there was absolutely no degradation measured. Of course, the steam generator will not degrade if you treat the water properly from the feed water pump. So short answer to this question would be actually that the performance degradation loss between the outages, and this is all recoverable, is about 1%.
Okay.
So for 6 years, you'll probably lose about 1%.
It all seems so nice, and of course, the next question will be about the price. So, Fabrizio, what is the installation cost?
Right. So, in terms of the concept and philosophy behind the design, overall was its simplicity. We wanted to design something that could be simple and easy to assemble and install in an existing plant. So that right away, in terms of construction cost or cost or risk potential, makes it lower, much lower. The other key advantage, of course, is the fact that we're using existing equipment. So in terms of the whole power generation side of things, we're using assets where their cost has been already amortized. So that all is another big advantage. The other, I would say, and talking to some of the utility clients, another key advantage is that for them, we are avoiding decommissioning costs. These are all costs that would have to be incurred in these plants. So a lot of the decommissioning costs would be saved. So I would say we are very, very competitive on a capital cost basis with any other storage technology. And obviously, we'd have to look on a case by case on actual capital cost, but the short answer is highly competitive compared to other storage technology.
Okay. Our next question is, can you use the E2S for cogen applications, for instance, for example, in district heating or other applications which also use heat? Sasha, I believe this one is for you.
Yeah, this is also one of those questions we get asked all the time. Yes, of course, we could use E2S for anywhere where you can generate heat. So we can generate heat, whether making it a steam or water. However, I would say due to the specific design that we are utilizing these MGA blocks, which really need to get heated to about 700 degrees to get the maximum out of the system. You remember that storage curve. If you need some lower temperature heat, maybe it's not the optimal solution. Maybe we would then go, instead of using the MGA blocks, we could then use simply graphite and operate at lower temperatures. But let's say our standard design and our main purpose is really to use it on the utility scale applications.
If I may add just one point, we do realize that a lot of the power plants that our host power plants, these plants themselves have cogen application or use some of the steam for district heating. So we are discussing with them also ways to optimize that and look at those applications as well.
Okay, thank you for the add-on. Another question, can you use the E2S for gas-fired plants? Sasha, for you?
Yep. Well, I come from gas turbines business, so of course, actually the initial idea of our storage was to facilitate the combined cycle power plants and potentially replace or assist the heat recovery steam generator, HRSG. So yes, of course, the levels of pressures and temperatures at the combined cycle power plants are similar to those of the coal-fired plants. Also, the temperatures between 500 and 600 degrees, pressures at about 150 bar. So this is all good for us. And we can even envisage in the future that, some of these old legacy combined cycle power plants will be also converted to the thermal energy storage systems, like our system as well. And moreover, I have to say something. We are currently talking to one of the major IPPs in Europe who are planning to build a hybrid power plant, combining solar, combining combined cycle power plant as well. And they also asked us to maybe propose them a solution which would facilitate that and add some steam from the storage fed by the solar power plants to the HRSG to optimize the performance. So the answer is yes, we can use it.
Okay, I will move on to the next question, and I would mark this as the last one because we are limited with time. Can your system provide ancillary services such as frequency response, load following, reactive power? Fabrizio, maybe you would like to take this one.
Yes, this is also a very important point. We realize that ancillary services can form an important revenue stream for a lot of our clients, a lot of the storage systems. So, first of all, the answer is yes. Clearly, as mentioned earlier, we are making use of the existing steam turbine generators. So a lot of the grid services, voltage regulation, frequency support, and so on can be provided by our solution. In addition, as we work with our utility clients, there are services such as peaking, such as cycling capability in terms of providing capacity that can also be provided by our system.
Yes, yes, and if I may add, in addition to all these capabilities which are typical for the generator, steam turbine, our system is improving the flexibility of existing thermal power plants. For one reason, typically a coal-fired plant will have a drum-type boiler, which needs long time to heat up. So you have all these holding points. You cannot start within less than 4 hours. Our system is in fact a once-through boiler. It doesn't have any drum inside when we're generating the steam. So therefore, it's much more flexible. You can actually ramp it up very quickly. And our only bottleneck in the system would be the steam turbine capabilities or the generator capabilities. But in any way, we are definitely improving the operational flexibility of the existing thermal power plants.
Thank you very much, gentlemen. And as I said, unfortunately, our time is almost up. I'm sorry that we were not able to answer all the questions, but we will get back to you via email. And let me remind you once again that the whole presentation will be available on E2S's Power YouTube channel immediately after this event. I hope you enjoyed and found this session interesting. Thank you, Sasha and Fabrizio, for offering a different perspective on how we can meet the urgent need for energy storage and can repurpose existing fossil-fueled power plants, contributing toward a CO2 neutral future, utilizing valuable assets and saving jobs. Thank you all for being with us today and taking active part in the Q&A session. If you have any additional questions or would like to discuss furthermore, you are welcome to contact the E2S Power team directly via email contact@e2s-power.com. Thank you once again for your time.